So hello everyone. So we'll continue the problems on the air compressors. So in the previous video we have discussed problems on single stage, single acting air compressor without the clearance volume. So you do not have the clearance volume there. And in this particular video we'll be discussing a problem on single stage air compressor but with clearance volume. So how to do a problem when the clearance volume is given. Let us see the problem in detail. Okay, a double acting air compressor. See this particular word here, the double acting is very important. So why? Because I will say you in the preview, like in the next part of the video. Okay, double acting compressor with piston displacement of 0.04 meter cube per stroke. So what it is the piston displacement, operates at 480 rpm. So rpm is given, the speed of the thing is given, the clearance is 4%. So the clearance ratio is given. So what is clearance ratio? We will find it out. And it receives the air at 100 kPa. So this is your entry pressure, I mean to say at the pressure at which the air gets entered into the compressor, and discharges at 500 kPa. So this is your discharge pressure. I was speaking about this and this. Okay, the compression and expansion is polytropic with PV is equals to PV raised to the power of 1.3 is equals to constant. That means the value of N is 1.3, which is given. Okay, now determine the power required and the air discharge. So you need to calculate the volume of the discharged air, and you need to calculate the power which is required to drive this compressor. How will you do it? First you have to calculate what amount of work you need to input into the system. So if you calculate the amount of work, then you have to multiply it by the speed of the compressor, which is given as 480 rpm here, multiply with the speed, then you will get it in the power required to drive it. Okay, that is how. So first you have to calculate the work done. So for the single acting reciprocating, see this particular expression is for single acting, but here it is double acting. We shall see what we have to do with. Okay, for a single acting reciprocating air compressor, we have what done from 1 to 2 is N divided by N minus 1 P1 into V1 minus V4 into 1 minus pressure ratio, which is P2 by P1 whole to the power of N minus 1 by N. Now, the piston displacement volume is nothing but V. Yes, correct? It is nothing but the swept volume, guys. So, I would generally discussing as the swept volume. Here he has changed the term as the piston displacement volume, which means the same thing. Now, the percentage clearance is given as the clearance volume divided by swept volume. Okay, and how will you calculate the Vs? Where is Vs? So this is your Vs from here to here. So Vs is nothing but this length, okay, minus this length, correct? If you subtract this length with the whole length, then you will get the value of Vs. So that is V1 minus V3. Next thing, he has given a percentage clearance 4%. So just substitute here 4 divided by 100 clearance volume. So this is your Vc, no? So from here to here is your Vc. Okay. So just substitute the Vc. Vc value. You need to calculate the Vc value anyway. Swept displacement volume, which is given as Vs. Vs is given, so substitute the value of Vs, which is 0.04 meter cube per stroke. Okay. Then you will get the value of V3 as, which is nothing but Vc, which is nothing but Vc. V3 is nothing but Vc here. So this is Vc. Okay, so that is given as 0.0016. Okay, so from this particular percentage clearance, you have got this value. Okay, first, why are you calculating all this? Is you need the value of V4 from this. Anyhow, we have to calculate V4. That is why we are doing all this. Okay, next. Now, in this particular equation here, Vs is equals to V1 minus V3. You know the value of Vs, which is given. V3 value we have just calculated here. So you can calculate what is the value of V1, right? So that is what I have done here. V1 is equals to V3 plus Vs. Just substitute the values and you'll get the value of V1 to be 0.0416 meter cube. Okay. Next, you can apply the PVT conversion equation from the process 3 to 4. So, what is process 3 to 4? Where is that? So, this is your process 3 to 4. Correct? Which process it is? It is expansion. Which expansion? It is polytropic expansion. For polytropic expansion, what is the PVT conversion equation? Which is from 3 to 4, it is P3 by P4, that is equals to V4 by V3 whole to the power of n, that is equals to T3 by T4 whole to the power of n divided by n minus 1. So, I require the relationship between volumes and pressures. So, I have taken that part of the thing. Here V4 by V3 whole to the power of n it could be. So, I have transferred to the either side, it will become 1 by n. Okay. So, substitute the value of V3, P3 and P4 are nothing but P2 and P1, just substitute the values. So, you will get the value of V4 here. So, once you got the value of V4, you can use the expression, work done expression here like this. Okay, so this work done expression can be used and substitute all the values since all the values have been calculated. So, you will get the work done to be negative. Why it is negative, guys? Because it is the work done on the system. So, compressor is a driven unit, right? So, you need to work on it. So, this particular amount of work you have to, this is 7.016 is the value, kilojoules in kilojoules. So, minus y because it is work done on the system. So, this is for the single acting air compressor. Now, for the double acting, you have to multiply it by 2. Why? Because, say for double acting air compressor, what happens? For a single rotation of crankshaft, you will be getting 2 work outputs. Correct? So, for single rotation of the crankshaft, you will be getting 2 work outputs. That is why you have to multiply it by 2 and the total net work output would be minus 14.032 kilojoules. Getting it? So, this particular thing is very, very important. So, if in the question he has mentioned it as double acting, then you have to multiply the obtained value of work done with 2 and your final answer could be 2 times the whatever you have obtained. Okay. Next. Power required, he has asked the power required. So, we have calculated the work done. I told you power required can be calculated as work done into speed. So, speed he has given, substitute in RPS. So, this particular speed here should be in what? It should be in RPS. So, he has given in RPM. So, divide by 60 there. Okay. So, calculate the value, it could be minus 112.25 kilowatts. So, this is the power required to drive your compressor. Now, volume of the air discharge. Volume of the air discharge is given by V1 minus V4. See, V1 minus V4 is also equal to V2 by V2 minus V3 because your air compressive process, just a minute, because your air compressive process is symmetric, like means whatever the value of V3 minus V2 or V2 minus V3 is there, the same value would be V1 minus V4 because this length is equal to this particular length in your air compression process. Okay. So, that is why I can write this as V1 minus V4 can be written as V2 minus V3 into speed, number of speeds in the sense for one particular stroke you will be getting 1 or 2 volume outputs. That is why it is double acting. So, it is, you have to multiply it by 2 here. Okay. So, you do not know the value of V2, I guess. So, you can calculate from the PVT conversion equation, applying it for the process 1 to 2, which is polytropic compression. So, you can apply the PVT conversion equation as same, which we have applied for the expansion process from 3 to 4. Now, we are applying it for 1 to 2, which is your compression. So, apply it. So, you will get the V2 as 0.012 meter cube. Okay. Once the value of V2 is known, calculate the value of V2 minus V3 as so much. Okay. And multiply it by 2 because it is double acting and with the speed because you have to calculate per second. So, the final answer of air discharged is 0.1664 meter cube per second. So, this is the problem on the single acting air compressor considering the clearance volume. So try a same problem, which is this: an ideal compressor has a displacement volume, which is the swept volume of 14 liters. So convert liters into meter cube. You know how to convert it. So convert liters into meter cube, and what else is given? The clearance volume of 0.7 liters. So directly he has given the clearance volume. So 0.7 into 10 to the power of minus 3 meter cube. It receives the air at 100 kPa. So the inlet pressure is given, and the discharge pressure 500 kPa is very much similar to the previous problem. The compression is polytropic with n value again 1.3. The expansion is isentropic. Okay, where the see here the expansion is different from the compression. So what happens, generally the process could be like this, correct? Both values would be of same. So if it is PV raised to the power of 1.2, this also could be PV raised to the power of 1.2, but here it is different for different. So be careful while doing this, solving this. Okay, determine the net cycle work and calculate the error involved if m is equal to n. That is a beautiful problem. So what you have to do, first you have to calculate, considering this as 1.3 and considering this as 1.4. Okay, and in the second stage for the same problem, what you have to do is consider this for 1.3 and even this as 1.3 and calculate what is the difference involved. So compare the both work done. So then if any problems while solving this, please contact me.